Hi, now we're going to look at one or two standard series. In the last video, we looked at sigma r equals 1 to n1 and discovered that that was n. And we also looked at sigma r equals 1 to n of r, which is 1 plus 2 plus n, and that is a half n plus 1. We need to know about two more. There is sigma r equals 1 to n of r squared, which is 1 squared plus 2 squared all the way up to n squared. This is equal to 1 over 6 n plus 1 to n plus 1. And also sigma r equals 1 to n of r cubed. Not a very good 3. Let's try again. And this is 1 cubed plus 2 cubed plus ... all the way up to n cubed. This is equal to a quarter n squared n plus 1 squared. That last one I remember by noticing that it is just the square of a half n plus 1. Just look at that. A half squared is a quarter. N squared is n and n plus 1 squared. So just squaring this gives me the top line. And that is sigma 1 to n of r all squared. It's just a little trick I use to remember that last formula. Those last two formulae, the sum of the squares and the sum of the cubes, at the moment, that's just too difficult for us to be able to prove. When you do the proof by induction chapter, you will find that we're able to prove both of those formulae without much difficulty. And there is another technique when you're doing the F2 module where we can prove those. Let's just use one of them. Let's find sigma 1 to 20 of r squared. Very simple. We just go to the formula for sigma r squared. 1 to 20, 1 to n, put n equal to 20. I should really have written r equals, and that is equal to putting n as 20, 1 over 6 times n plus 1 times 2n is 40 plus 1. And if you press the buttons on that, you get 2870. What about another one? Find sigma r equals 10 to 20 of r squared. Just have a little go at that for yourselves. Piece of paper, pen, pause the video when you've done it, start the video up again, and I will show you how it should be done. Well, did you manage that? What are we trying to find out? Let's just make sure that we've all got the right idea. We're trying to find out the bottom number is 10. So this is starting with 10 squared. Next number up is 11 and 12 until we get to 20. Well, you need to think like this. This is 1 squared plus 2 squared plus 3 squared, etc., all the way up to 20 squared. Take away, well, we need to take away 1 squared, 2 squared, 3 squared. We don't want to take away 10 squared because we need it. So the last number that we're going to take away is 9 squared. This is a common mistake when you don't think carefully. So this is sigma r squared from 1 to 20 minus sigma r squared from 1 to 9. That's r equals 1 to r equals 1 to 9. Let's make that look nicer. Notice that our formulae all start from r equals 1. So we have to go back to r equals 1 to be able to use them. The first one we've already done, that is 2870. The second one is 1 over 6. N in this case is 9, so that's n. N plus 1 is 10. 2n is 18, plus 1 is 19. And if we press the buttons on that, we get 2585. So not difficult, but if you're careless, some people subtract sigma 1 to 10 instead of 1 to 9. A little bit of thought shows that that shouldn't be done. Okay, let's move on. And what happens if we now look at sigma 1 to 4 of 3r squared? That's r equals. I'm very bad at remembering to put r equals. This is a very simple example so that we can see what's happening easily, but the principles we're going to see will work even if I did r equals 1 up to 400. But that would take a long time to write out. It would be nice if that was equal to 3 sigma r squared. That would be nice. But this is something that we must check and have a look at for ourselves first. What is this equal to? Well, I put r equal to 1, I get 3 times 1 squared, plus. Put r equal to 2, I get 3 times 2 squared, plus. Put r equal to 3, I get 3 times 3 squared. And put r equal to 4, I get 3 times 4 squared. Now, writing it like that, you can see that the sigma really behaves as a very large bracket. Which is 3 times sigma r equals 1 to 4 of r squared. It's what we wanted it to be. So that's fortunate. Okay, let's look at another result. What happens if we take sigma r equals 1 to 4 of r plus r squared? Once again, if you look at that, it would be nice if this came out to be sigma r plus sigma r squared. But we ought to have a look and make sure that it does, or perhaps that it doesn't work. What is this equal to? Put r equal to 1, 1 plus 1 squared. Put r equal to 2, so plus, put r equal to 2, 2 plus 2 squared. Plus, because of the sigma, r equal to 3, 3 plus 3 squared. Plus, r equal to 4, 4 plus 4 squared. Well, we're used to playing around with numbers. Let's just reorganize these. And having done that, we can see that this is equal to sigma r equals 1 to 4 of r plus sigma r equals 1 to 4 of r squared. In other words, we can just split it up in the way that we would like to do it. So we have two results now. We have this one at the top here, and we have this one at the bottom. So I'm now going to use those two results, or generalizations of them, to do a fairly typical example using sigma squared. or sigma, sorry. So let's move that up, keep that result at the top showing, and we have this. Let's take an example. Well, I didn't really want red, so let's go back to blue. Let's find sigma r equals 1 to n of 2r plus 5r squared. Well, the first thing we're going to do is use these two things in red just above to simplify that. The plus means we can split it into two separate sigmas. So we can have sigma r equals 1. Let's move that across a little bit. R equals 1 to n plus sigma r equals 1 to n. Then in the first one, we would have sigma 2r, and that's just 2 sigma r. And then in the second one, we would have sigma 5r squared, which is 5 sigma r squared. Now, you will have probably forgotten the formulae that we had on the previous page. I will tell you what they are as I do them. This first one is 2 times sigma r is a half n plus 1 plus 5. Sigma r squared is 1 over 6 n plus 1 to n plus 1. So that's just using the formulae which are further up the page somewhere. I will do one little bit of arithmetic. 2 times a half is 1. So I can ignore that. Now, one thing that you must always be looking for, it's a waste of time completely to multiply this lot out. Always a waste of time just to go ahead without thinking. I can factorize. I've got an n here and I've got an n here. I've got an n plus 1 there and an n plus 1. So if you can factorize, the guiding line is always factorize. Some people stop at that. I think that's a pity. I don't like fractions. This 6 on the bottom, I will also factorize. Now here, some of you might find it a little bit difficult to cope with what's happening when I try and take a 6 out from this. Well, here's a little trick, not something you need to write down unless you like to. If you think, instead of that, of thinking of 6 over 6. Now, look at this first expression. I've taken out the n on the top, the n plus 1 on the top, and I've taken out the 6 on the bottom. What am I left with? The 6 on the top. So that leaves me with 6. And in the second one, this is easier to see perhaps because it's all sitting there. I've taken out the n plus 1, I've taken out the 6, I'm left with 5 times 2n plus 1. And that is just n plus 1 over 6. And inside the bracket, inside the bracket, I have 10n plus 6 plus 5 is plus 11. So that is a fairly standard, simple little problem, which you are expected to be able to handle easily. All that I've done here, you can find again and a little bit more in your textbook, FP2 on pages 116 to 118.